Good morning. I'm really glad to welcome all of you. I'm really glad to see so many people. It's very nice. And I would like to begin this track with approaches to building safe architecture, starting with the most modern and the most technical options, how it can be done, and all the way to Socratic's method, which, as we are going to learn, works more reliable than anything else. The main idea of my presentation is that it is very important for us to provide not just safe architecture or separate systems, but we also should think a lot about connections between different systems. And in these connections, we have a lot of problems there. 20 years I've been working as an architect, building IT systems, safe architectures, and I've seen a lot of different enterprise systems, startups, applications from the side of a vendor, integrator, and client. So I do understand what problems can happen in real life. We have almost learned to build safety of separate applications with consideration of the fact that some attacks are successful and we are not able to do that, but more or less, we've been able to work with some applications. We have different blueprints, we have recommended best practices that we can use in order to provide safety of one specific system. However, the problem is when one of the systems was implemented, from the safety point of view, it starts degrading. For example, we don't have some patches, we have some new integrations, we have some exceptions, and together with the development of the company, it comes up that safety is not developing but degrades. So I do like how the old castles look like. It's a great illustration of how IT system looks like that were developed a long period of time. So we have the company that have built something, that they have touched something else, that touched the third thing, and in the end run it looks like that. But speaking about the IT architecture, it's not like that. We have a server, it looks irrespectively to our architectural composition, but this is the illustration that I want you to hold in your hand as an overview of what do we get when we start adding new integration systems and develop our business applications. Ideally, we would like to see great enterprise infrastructure. Then all information will be in a single system, moved in physical, logical, business architectural levels. And when we enter the single application, we will be able to see the condition of any system that we have, that we own. And ahead of us, we're going to have two presentations where colleagues are going to tell you about the principles and approaches and building enterprise architectures and how it looks like. However, unfortunately, in real life, this ideal picture, we don't see it pretty often. Usually, architecture is a set of absolutely different, not really interrelated documents. For some systems, these are some text documents, somewhere we store something in Confluence, something is in emails, something is in Telegram. And it is good when we have description of the safety architecture for every system that is present with us. However, in real life, it happens like that. Some document was lost, other document was not restored from the backup, another document went outdated, and we don't have single understanding of what do we really have in our infrastructure. So the main problem is not documentation. Documentation is very interesting when we go through another audit or when we need to confirm the compliance to the requirements of some regulator. The problems are in the interconnection of our architectures, and these connections, they grow through some unexpected thing and start leaking. And my favorite example from audit practice, when there was a company which had a system where they stored a lot of confidential data, and everybody were confident that this data is encoded and wonderfully encoded. And those who've been developing this application, they were absolutely confident that decoding is on a database level. Those who've been responsible for database, they thought that encoding was done on the level of OS. Those who've been responsible for the infrastructure, they said we had hard coding and it's done on a hardcore level. And those who've been responsible, they thought that it works somewhere upstairs and they have not been switching. And then, as a fact, we figured out that everybody has made an assumption that encoding is built somewhere, but because we didn't have a single picture, it happened that we didn't have it at all. Well, we do like We are encoding data when we transfer, store. But backups are not being encoded than those. Of course, if you have those backups, if you have backups of your encrypted system. However, what else? On connection of systems, we can see a lot of different users who are trying to get around those systems and different limitations. And ahead of them, there will be a wonderful presentation about the human factor. That's why I'm not going to give you spoilers, but I will go to more technical things. So if we're going to speak about attacks, in principle, the criminal needs to find this interconnection between systems, and they are leaking between different systems where the protection measures have not been divided. So I would like to say that everything starts that malicious actor collects the data and all the press releases about how wonderfully we have implemented systems, collaboration, and this is the information which is very good for the malicious actor. PR and marketing, they will make those statements, but we have to understand that information about inversions and other version-related information can be acquired. Then this actor tries to get into the system, penetrate the system, according to the recent data, and this is usually human factor. Phishing letters, sometimes. This is a well-known accounts or legal accounts with legal passwords, when users didn't care about the second factor or the reliable password. But the most awful thing, when the criminal receives access to the system with minimal rights, it takes approximately a few hours or a couple of days before he gets full system rights. A domain administrator or admin who can do anything in the system. And statistics tells us that in some cases, up to 200 days and more, criminal can stay in the system undiscovered. So they're hiding in those slots between systems. And the question is, what is to be done about it? The most important moment is we need to try to think the same way as a malicious actor and how he penetrates into the system. As for the actors' activities, they are well documented, and the best option of documentation is attack matrix, which describes the techniques and tactics, how the criminals get into the system. So the previous scheme that I was showing to you is deployed into more technical actions done by the malicious actor. And this is one of the ways of building integral safe system. So when we have implemented a lot of different systems, implemented a lot of business applications, launched a lot of integrations, what do? We are trying to think how the system can be broken. So what do we do for that? We look at those techniques and tactics that criminals have, and we are trying to realize them. In such ways, well, three main approaches. The first and the safest one, so-called desktop applications, when we sit down together with architects and we start discussing what can be realized out of it. What's so good about this way? It is not going to break anything, well, except for the table if we're going to argue. The next one is invasive ways, when we try to check it, or when we're trying to order external pen testing and we try to check these tactics in practice. The latest one is the most reliable and most risky one, because if we have those problems in the system, they will be discovered. What else has to be understood is that there is a difference in the system of thinking of a human who provides safety and the person who is trying to attack. In most of the cases, unfortunately, our mind is destroyed by legal documents. So we are thinking with lists, Excel tables, and points, bullet points that we have to follow. We have a checklist out of 100 or thousands of bullet points, and we're putting check marks that this measure has been taken. But criminals, they think graphs. They have nodes, they have connection between those nodes, and he's trying to build a route how he get around this graph. And it is very important to change the thinking towards the graph and not listed one, so that we can think about how can we get from one system to another. And there is a good way to model such a system. Basically, we can build system as those graphs. So we can build our system like that. But unfortunately, as I've told you, the problem is with a single enterprise infrastructure. So this graph, it's going to be difficult to build it. But I do hope that our colleagues will tell you how these can be reliably provided. But the second option is to try to build the solution tree. This is traditional way of solving these problems from the theory of limitations, which tells us that we need to break a safe and therefore how it can be broken. And then we take all possible options, explode it, solder it, find brute force the safe, and then we start inventing methods. How can we neutralize this problem in the system? The second option is more interesting and connected to the system is the data flow modeling. We are trying to connect the systems between each other without not looking at the architecture and safety of each system separately, but build a single flow of data between those systems. So the main idea is in what? We have systems, we have systems which are responsible for the application logic and systems responsible for data storage. So between both of them, we have data flow. What else is important? That different systems are located in different safety zones, and we have to understand when data flows from one safety zone to another safety zone. Let's speak in examples. For example, if we're speaking about the same audits or pen tests, we are inviting a company that does the audit of information security. They collect system-related information, write reports, and store this report in their system. In this report, they have information about all vulnerabilities and problems with security that we have. Do we know how and where auditor stores this report? So this is the most interesting and critical data about our security, which is stored precisely not in our system. It is stored somewhere outside. And how often do you check the storage of audit-related data on the side of your auditors and provide requirements to the safety of these storage systems? If in your agreement you cannot provide this, one of the options is that you should do it in such a way so that these data shouldn't leave your system. This is a little bit more expensive, but in the framework of financial audits, very often they have a practice when auditors arrive to the client, they work on the side of the client, and all the data, all the intermediate results are stored specifically in the system and the client's infrastructure. And only that part of financial audit, which is public, is transferred to some external systems. More usual example is mail. We have used to the situation that we have a mail that we use. At the same time, there's always a question, what really happens with mail messages that we send outside to clients, contractors, partners, etc.? Well, in mail, very often mail contains confidential information. And if we do provide good security on our side, we cannot control how this letter will be stored on the side of the client. Moreover, when by accident we add some addressee which looks like our addressee and the letter flies to them, we cannot control where this data will disappear. We can control configuration of our mail server and require installation of at least protected network connection. However, at the same time, messages, the ideal option is when we try to encode them, because the confidentiality problem can be solved by encryption. But encryption of the messages is that we have either very old PGP or S-MIME, which are not really common, but they help us to encrypt messages and be confident that they are protected. Or once again, if we don't want for this information to leave our counter, then we don't send it through the email, and we create some internal system which allows us to work with these documents, different data rooms, etc. What else? When we speak about data modeling, then we have several threats from which we would like to protect ourselves. There's a very old but still reliable Microsoft Stride methodology, which allows us to look at main problems with information in our systems. The idea is we look at our data flow. We see when it moves from one zone to another. And then we see what can go wrong with this data on this borderline and what can go wrong within those systems where they are in. What are the options? It's data spoofing and changing of the information, raising escalation of the privileges, and data blockage attempt. So what is the main idea? We are looking at what can be realized from these attacks. Some of these things are not really critical. For example, if we're speaking about the internet store, from one side we have card-related data provided for the payment. On the other side, we have product-related information. So to provide confidentiality of information about products, well, it shouldn't be done compared to the credit card data. So we have to look at the security that has to be provided. However, it seems that we have approached as zero trust, and the concept that is being promoted, and it has to solve all our problems. And what zero trust tells us about that, we trust nobody, we always check. In other words, we take any arrival to our system, we look where it comes from. So we go from the perimeter architecture, we think that criminals can be even inside of our system, and we start checking every. But the zero trust, it's not a technical term, it's a marketing term, which looks beautiful in advertising booklets. But we cannot work in zero trust system. We have to trust somebody or something. We trust the system that checks these access. We trust the system which gives the access tokens or certificates for the users, which are checked for authentication. We trust the OS, which transfers this information. We trust the equipment, server equipment. So we have big layer of trust, indirect trust. And what is very important about it is when we move to zero trust from one side, we think that we are checking every addressing, but on the other side, we have certain layer of these systems which are trusted indirectly. And the most dangerous thing is to trust to systems which provide zero trust. On one of the last Black Hats, there was wonderful presentation. How did it happen, and how can you get access to system through the zero trust system? Well, I would like to tell you this story because it's a very obvious story, and it tells us about problems of configuration and the connection between different systems. Those guys, they've been testing AI solutions in the clouds. It's a very popular topic, artificial intelligence, everybody trying to train their models in cloud infrastructures. And what those guys were doing, they've been checking how this security is provided in clouds. And they've been checking it for vendors like Microsoft, SAP, how they provide services through these systems. So what is the idea? Clients purchased client access to the cloud infrastructure to deploy and train their AI models. And they were able to acquire access to all the system data and API keys of all other clients in this cloud.
В чем была идея? Вся эта инфраструктура крутилась в контейнерах.
This infrastructure was in the containers, and problem with containers is that they disappear. It's a big problem from the security point of view. You cannot learn about ports or anything that is happening. They just disappear. They don't log. So they started using service mesh.
It provides recommended solution for zero trust. I mean, between all the microservices, you get protected connection, and it's being checked. Well, what's the point? For this mesh service to be operational, you have admitted ports which can bypass firewall. So on a virtual machine, a container which has been received by the client, it was possible to customize yourself and go beyond this container using these credentials which have been used under the zero trust system. And then by spinning off this problem with writes on the level of channel packages, they were able to get access to the images of other clients' containers where they had IP keys of access to different clouds. Well, the idea is that even if we introduce the zero trust system, we cannot trust it. We have to double check on the system, on the configuration, and we also have to double check on how the integration with other system is being set up. And what can be done here? Again, unfortunately, right now, more and more we can see that older methods actually work very good. So when we talk about the trust between different subnets and so on, isolation seems to be the best. If we have a zero trust solution and we do not trust it, what can be done? We can do an isolated subsystem which does not have connection to the internet and store all the valuable information in it. The next thing that we have to double check somehow on how we've built the architecture of our system. And basically, almost all modern framework, trees, limitation theory, and so on, they are based on the Socratic method. So it's enough only to look back on how to search for the truth and how to engage in a dialogue. What is important? It's important to ask questions. And it's not even about whether they're smart questions or, like there is no stupid questions. It is very, very important to ask questions. And then to analyze what kind of answers we've received and what kind of contradictions have been identified, and to ask, to question everything. When we introduce any solution, like why do we do that? What it's going to give us? What kind of new risks it's going to bring? So I believe that introducing any new solution may bring actually more risks than its implementation. And after that, having asked the maximum number of questions, we understand what to do with this particular system. Does it have to be introduced or not? But this is not the end. Again, let's remember that it is not enough to think by lists to be able to ensure security. After we designed a certain system, we begin to think in graphs. We begin to think like where this system is, what it is connected with, and how it communicates with those systems. One example. Whenever we talk about an office, everybody's going back to offices, people do not work remotely anymore, and we have some stations in the office. Unfortunately, up to this day, a huge amount of these workstations don't have the local firewall to block traffic between the local stations. It may seem like there is a scenario with a Skype, but Skype is dead. When there is a peer-to-peer communication between employees with workstations within one office, right? So there is no communication because everybody is communicating via server. But local firewalls have not been activated on many workstations. And this is a huge loophole for attackers because having compromised just one station, by network they can travel across many stations and connect hashes, passwords and keys, whatever you want, to be able to escalate their privileges in the system. And again, whenever we think about some new access or about some kind of permissions, we have to think, why do we need them? Are there any reasons for them to be a part of our operations? And summing up, what can be done? Like I said before, we are trying to think through all of our system, think in graphs, not in text, and see how the nodes are communicating and pay special attention to the interface or connection between the systems.
Итоги. Соответственно, мыслить комплексно, резервировать систему.
We're back. I apologize for delay. So we gotta be backing up not only security system but also microphones. And always we have to keep in mind, we have to double check that if we have a certain system, indeed, do we trust the system? And if we do, why do we do that? Because oftentimes we have some non-obvious trust, like for example the certification center, authentication center, and then we use this certification. Where is the guarantee, however, that this verifying center indeed generates very safe keys? we've had one vulnerability in Linux. In Linux library, they were generating keys, and if a person at least once would sign something with their digital signature, you could restore its closed keys. Because the keys have been generated not in a reliable way. They decided to save several milliseconds on the speed of generation, but this did not turn out to be good in terms of security. So this is again the questions about this kind of covert trust dependent on the system we work with. So it is important to ensure security between different architectural solutions and think in graphs. Thanks for your attention. If you have any questions, I'll be very happy to answer them. Thanks a lot.
Передайте, пожалуйста, микрофон.
Microphone, please.
Здравствуйте, Стас Очков, Анна, спасибо за доклад.
Hello, Anna. Thank you for your presentation. You begin your presentation by saying that you gave an example when there was an architectural problem. So, when, let's say, every layer or every department of this architecture, they would postpone or kind of kick the can down the road onto either a lower or higher level in the whole architecture. So this whole communication, this list of graphs, how do you go about that? How do we simplify it, to be able to make interconnection between the different stacks? And how can I shorten my graph possibly, and how can I understand that this authentication that I've done, that I did it correctly? For example, NGFW. I'm installing NGFW. Now I have to double check, do I trust it or do I have to do anything else? Thank you. Yeah, the first answer is yes, you have to understand all these interconnections. Like I said before, our architecture is usually a big number of fragmented documents for each system. We do not have a common picture because storage is a different system, and then operational systems and databases and applications, they're all separate systems, not interconnected. And secondly, all the assumptions. If I believe that encryption has done somewhere outside, it's being specified, but again, this is not the part of my architecture documents. And another thing is to do testing in-house or outside. And if you do the testing, it's an identification, the most obvious mistakes, and the most reliable thing, of course, to do modeling and to see what is happening. Right now, with computational capacities, it looks like it's not a very big problem, and we can even mathematically go about it, by the full document of everything you have. Yes, I think we have time for one more question, please. Hello, my name is Dmitry. And what if we have some tools, centralized tools of a built-in architecture? Are they available? Yes, we have them. There'll be 2 more presentations about them. Thank you. Sounds good. Sounds great. Thanks a lot.